Pay no attention to the big divot you took out. Thank you, sir. So what we're looking at here today is going to be a bunch of properties and parallelograms. And from what I've understood from talking with the second hour, is that most of you guys have seen some of this stuff. This really isn't going to be all that crazily new to go with you. One of these days, you're just going to switch classrooms on you. You won't even know what's going on. You're going to show up in the class and speak in French. Bonjour. Believe everything you hear on the internet. Bonjour. This is commercial. Shut up, So as I was saying, I know that you guys have all worked with parallelograms. It's one of the reason we start getting into parallelograms today is because we're actually going to be talking not just about parallelograms, but we're going to be talking about what are called quadrilaterals. Quadrilaterals. Actually, I think it's RI, but whatever. We're going to be talking about what are called quadrilaterals. Quadrilaterals are polygons that have how many sides?
5.
4, because of the word quad. I know it's tough, so bear with me. You'll be okay. All right. So when we talk about quadrilaterals, we're going to talk about basically parallelograms and non-parallelograms. Are you okay with my abbreviation of parallelograms?
No.
You'll get over it.
Okay.
Truth hurts today, doesn't it? So what we start out with today is we're basically going to be working with the family tree of parallelograms and versus non-parallelograms. We're just going to kind of get through rules of parallelograms today. It is pretty painless. Remember, tomorrow I'm going to be we'll be working on the final stuff and review stuff. So you'll be working on basically the same thing you did yesterday and today, tomorrow. On Thursday, it's perfect for a half day, is to work backwards. So then that way on Friday, we're still going to have a very short quiz on that stuff on Friday. So it won't be, this is not going to be a real difficult thing to roll through. When we go through all the different things in parallelograms, remember, we're going to be talking about what are called family trees. And remember, as you go through family trees, every step below something has all the properties of the stuff above it, okay? So parallelograms and non-parallelograms, well, they're both quadrilaterals because they have 4 sides, and so on, okay? What we're going to do here is eventually we'll talk about rectangles, rhombus, squares, kites, trapezoids, and so on. Over the course of this entire chapter, that's what we wind up talking all about. So don't worry about what we're getting towards, but for now, the reason why we're branching off to the parallelogram part is because those are pretty easy. Okay? And within all these shapes are going to be specific properties, and each one of the properties that this has, the next successive group has. It's kind of like the biology was the family, was it genome, species, origin? Is that right, or am I wrong? Is it genome, species, origin? I don't remember how that goes. Oh, don't worry about this. I'm just saying this is going to be a trapezoid. We're getting to all this stuff. This is just, I'm just speaking, just saying out loud. We're going to learn all about all this stuff later, I must say. Okay. But am I right? Is it genome? Is that the main one, or is it species? I don't know. I don't remember. I don't remember. But you know what I'm talking about, right? So if you look at what I'm going to generically draw out as a parallelogram, what is some property that I know that you guys all know about a parallelogram?
Parallel.
What are parallel? Sides that don't touch? All right, you said top and bottom, but what happens if it's like this?
1, 2.
How about opposite sides?
Yeah.
Does that work? The side, I like what you're saying, the sides that don't touch too. So opposite sides are parallel. We'll make a little running tally of stuff that we're going to do here. So parallelograms, properties, opposite sides are parallel. Okay. What's something else you might remember?
They don't intersect.
That's fine.
You left.
All right, let's go back and think of this. When you have parallel lines that are cut by a transversal, thank you. What do you know about consecutive interior? They're what? The same? Not necessarily, they could be, but more specifically, what do we know about those two angles? They equal 180. When we say they equal 180, what do we call them? Supplementary. Okay. So what happens here is that since your lines are parallel, these sides act as transversals, which gives you these two angles being supplementary. Now, if I turn and I just kind of throw a number at it, just for argument's sake, if this is 80, what does that have to be? 100. Okay. Now, if I go the other direction and I say that this one's parallel, and those are my parallels of my transversal, isn't the 100 and this angle on the same side on the inside?
Yeah.
Which makes this angle here how much? 80. Which makes this angle down here 100. What I'm getting at here, guys, is that when you're working with parallelograms, whatever angle is next to you will always be your supplement, no matter what. Whatever angle you're at, if I'm at this angle, if I go to my right, it's my supplement. If I go to my left, it's my supplement. If I'm here, if I go here, it's my supplement, and so on and so on. So what we say is consecutive angles are always supplement. Consecutive angles will be supplementary. What else can you say about the angles? Just looking at the generics that we have here. What's that? Look at the angles across from one another. What are they? They're equal, aren't they? But we don't say across from one another, we say opposite. So we have opposite sides parallel, consecutive angles supplementary, opposite angles are congruent. And there's a couple other. One of them you probably you're just completely overlooking. The other one might be a little bit different. Think about the sides. What's that? Which ones? Yeah, very good. And that's it. When you have parallelograms, you have opposite sides that are parallel, but they're also going to be congruent. They have to be the same length. That's how that you are able to create the angles. So you've got opposite sides parallel and congruent. And the last one might be different, might be new to you. The last one deals with what are called diagonals. The diagonals inside parallelograms go vertex to vertex. You guys have all heard that before, right? And the vertex goes from, the diagonals. The diagonals go from vertex to vertex. They create the diagonal within the parallelogram. And the one thing that happens with these guys is that they bisect each other. If you bisect something, what do you do to it? You cut it in half. So it doesn't necessarily mean that they're actually congruent to each other. All they do is they bisect each other. So we say that the diagonals bisect. And what's going to happen is that every single one of the parallelograms that we talk about throughout the next 4 or 5 sections and whatnot, if it's a parallelogram, it'll always have these properties. What's going to change is that within each shape, there's usually one or two other more specific things that can happen. For example, what happens when you have congruent angles? What kind of a shape would that be if they're congruent? Consecutive angles are congruent.
What?
If your consecutive angles are congruent to each other, what would they? Remember, they both have to have to equal 180. If they're congruent to each other, what will those angles be? 90. Which means, at the very least, you would have to have a rectangle. It's little things like that that'll change up. If you have 4 sides that are the same, what do you have? Not necessarily. You could have a rhombus. What's that? Nope. A square is a rhombus, but a rhombus is not a square. Okay? It's like a square is a rectangle, but a rectangle is not a square. Same thing with rhombus. A square is more specific than a rhombus. We'll get to all that, so you don't have to worry about any of that now. Okay? But fairly simple, isn't it? I think for the most part, most of these things you guys have seen, except for probably the diagonal part, right? Which means we can do stuff like this. If this is a parallelogram, and F is 132, is G a consecutive angle or an opposite angle? Which means it has to be equal or it's supplement. There you go. I know this is really painful. I'm sorry. So the supplement to 132 would be? It's nice to have decent math for a change, isn't it? What would H be? 132. What would G or E be? 8. So, does any of this change if you throw algebra in it? None of it will change at all. For example, if this is a parallelogram, figure out what X and Y are. I know. Pace yourself. Pace yourself. Tell me. No. Like we go down there. Take your temperature.
Okay. Get a Snickers, not you when you're hungry.
What about keep that in mind.
It's not hot. Yeah.
So what's X?
2.
2. What's Y? 17. There you go. Quick and painless. Remember, opposite sides are congruent, opposite sides are parallel. So you just know that these two have to equal each other. Like I said, very, very nice, easy math for a change. Okay. you guys are just always waiting for what can be weird sometimes is when you're dealing with diagonals. When you're dealing with the diagonals, you have to be careful about what segments and stuff that they're giving you. Now, it takes a little bit of time to get used to how they label stuff in diagrams and stuff like that, especially in books or worksheets and what. Now, when you see this, the suggestion that I would give you guys, when you're looking at the problem, the information for which parts go with what, they're usually on the same side of the diagonal. See how the 9 and the 2n minus 1 are on the same side of it? And then the n plus 8 and the 3m are on the same side? That usually means that they go together. Okay? That's usually what you will see. Every once in a while you might see something flipped around, but it's more or less, they try to design the problem, they try to write it out so that way it's not as difficult to figure out what's going where. Okay? We do a lot of work throughout the course of this really second semester dealing with internal segments on things. You'll see them in circles, you'll see them in all in the right triangles. You'll see them in all of the areas and volumes and stuff like that as well. Okay? So when you set this up, we know that they have to be bisected. Okay? So you know that those two individual segments have to equal each other. It doesn't say that they equal a certain value. It doesn't say they equal 180 or 360 or anything. All it says is that we know that they bisect, so they have to equal each other. So you wind up with pretty quick math again. And it's not that any of this algebra that we're going to be working on is going to be over anybody's head here at all. M plus 8 is 3m. What do you do first? And you get 2. So what's m? Good. And then on the other one, what do you do? Add 1, and then divide by 2. What do you get? A lot of you guys probably could have looked at that and said, oh, that's going to be 5. And if you can, great. I don't care. Write it down. It's fine. There's nothing wrong with that. Perfectly fine. Does it get worse? About as worse as this gets is when you have to read something to understand what it's asking you to do. I know reading is hard. But I have a smidgen of faith that you could figure it out. Not a lot, not like a smidge. I have a smidgen. Smidgen is smaller than a smidge. Makes sense. Okay. Now, one of the things that I would do is you look at the problem, it says that symbol, what do you think that symbol stands for? Parallelogram. Okay. It says parallelogram WXYZ. Angle W is 50 degrees more than angle X. Sketch the parallelogram and find the measure of all the angles. So when you draw up the parallelogram, can it kind of just look like that if you want?
Yeah.
Does it matter where you put your first angle?
No.
Did it matter where we put our first angles and triangles? No. As long as we put the letters in order. What's that? See how it's labeled WXYZ? If I put W here, the next one I write down has to be X. Like WX,
Yeah.
it works that way too. As long as you're going in the order of the letters, it's fine. Yeah, you just can't go across them. Because by doing that, it tells you the correspondence of which angles would have to be congruent to each other. Because remember, opposite angles are congruent. That means in this diagram, these two have to be the same. These two have to be the same. When you put angles next to each other, that means they have to add up to equal how much? 180, good. So when it says that angle W is, what's the word is mean in math? Equals. So I know that I can write this. Bonjour. Anyway, W is 50 more than X. 50 plus X, right? And what does W and X have to add up to equal? 180. Since I know that W plus X has to equal 180, I can substitute that in. And you're creating a very quick algebra problem. Guess what? So 50 plus X is 180. What's X plus X? 2X. Now you're back to a very quick two-step equation. What do you do first? Subtract the 50, good. And then what? Yes, Gary. X plus X. They're saying angle W and angle X, see how they're next to each other? If I add those two together, what does it have to equal? 180, good. Now, the first step said that angle W is 50 more than X. So instead of saying W plus X is 180, W is 50 plus X. You're creating what's called a system of equations to solve this. Okay. And what do you get for X then? 105. $65. So if X is 65, what's W then? Add the 50, you get 115. What's Z? 65. And what's Y? 15. Using the properties to work yourself through it. It's quite literally some quick substitutions. It's not real difficult. It's just knowing how to just write it out, honestly. And as you write it out, just take your time doing it. I think the only other weird thing that happens is that you might get a larger, you'll see a lot more larger diagrams where you can start at one point and work your way through an entire process. For example, it's this one. Pull this up a little bit here. In this is a parallelogram, A, B, C, D. And they're giving you 3 angles. If you go through the entire thing, you'll notice that there are 12 total angles. There's 12 total angles there. You know 3 of them, which means how many are left to find? 9 of them. By using properties of parallelograms, we'll be able to do that. So take a second and draw that out, and I'll kind of help you guys set up one of these. Where's a good place to start, and how do you walk through it slowly?
Oh.
Guys. So looking at that diagram, where do you think the easiest place to start might be? That E, yeah, exactly. I would definitely start right around E. The reason why I would start around E is because what do you know about the 117? It's vertical, correct. If I go to where that point where the letter E is, it's the vertical to 117. So I can write this as 117, which means how much is this angle here? It's 63 because it's the supplement because it's next to it. Okay? So 63 is the supplementary angle here, which makes the other side also 63. Good. So far, so good? Okay. Now notice, you have triangle AED. You have 2 of the 3 angles in the triangle. What do they all have to add up to equal? 180. So if I take out the 180, or take the 180, take out 80, I'm left with what? 100. Yes, there's the 63 still there. If I take the 63 out of it, then what am I left with? Bless you, 37. Good. So there's 37. I do the same idea with the AEB. If I add 117 and 23 together, what do I get? 140. Well, how many degrees are left if you have 140 to get to a triangle? 40. Good. So up here you get 40. Are we okay with that? So now we have to figure out how do we balance this stuff to get to the other angles. This is where using our, what do you call it? Properties of parallelograms, our parallel lines, and our transversal. So if I look at this carefully, 40 is right there, isn't it?
Yeah.
If I follow that transversal via the Z, the backwards Z that I made here, if I follow it, I come this way, down, and here, which means this much here is how much? 40. Okay. I do the same thing with the 23. If I follow the Z, 23 has to be here. Which means then what has to be there? And what has to be here? 37. Another reason why you can do that is because, remember, opposite angles have to be congruent. 23 and 37 has to add up to equal 23 and 37. So that's what you're going to start to see here, guys. You're going to start seeing larger, give you a couple of parts of a diagram, and you'll be able to figure out the rest. It just takes a minute or two to go through it. But as you can see, none of that math there was hard, was it? You didn't have to do any formulas. It was just filling in the blanks. Then again, you can play about everything. So I could give you $5 if you complain that it wasn't 6.
Forgot that one son.
Oh. So far, so good? The last little bit that's in here today is this really simple theorem. When you have three parallel lines, it's kind of weird that they put this in this section. It used to be in a different one. If you have three parallel lines and you have two transversals, if excuse me, wait for you guys to get caught up here. If two of the segments on one transversal are congruent, then the other two segments on the other transversal have to be congruent to each other. So if these two are the same, then those two have to be the same. What's that? There's a lot of stuff that happens like that. The reason that it kind of works itself through is because you get this. And they're saying that if this segment's been basically bisected, that means the other side have to be bisected because properties of parallelograms. Don't worry, you're not going to have to prove any of this stuff. We're not doing any proofs here at all. And that's really all it is. And quite honestly, the problems that you'll see with this is that these might have like an 8 and an 8, and this one is 12. What's that? Pace yourself, Miles. It's a lot of work ahead of you, man. That was too fast. Yes, I'm sorry. Yeah, it's quite literally all it is, guys. You'll get 12 here. Okay. Or they might say something where you'll have like an algebra here and algebra here, set them equal to each other, solve for x. It's not going to be difficult. It really, really won't. So I kid about slowing down. So do those. Please and thank you. Yep. You're like, are you serious? That was pretty good. All right. We'll go through those. We'll try that out. We have a whole bunch of stuff to go over then for Thursday. Shouldn't be a big deal. As you can tell, these first few sections are really, really, really easy. So. Thank you, sir.